Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x equals x. Now what I'm first going to do is I'm going to divide by x on both sides. So we have x to the power of x equals x, and if I divide by x on both sides, well, first off, on the right side, x divided by x, well, that's simply 1, because anything divided by itself is 1. Now, on the left-hand side, we have x to the power of x divided by x. And x here, our denominator, this can be written as x to the power of 1. And if you guys recall an important property of exponents, it states that a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So this is the formula for dividing exponents. So right here we have x to the power of x divided by x to the power of 1. And x in this case is a, x is m, and 1 is n. So if we put our variables into this form, we get x to the power of x minus 1. So now we're actually going to rewrite this as another, before I rewrite this, another important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x minus 1, this would equal x to the power of x times x to the power of negative 1. And this is still equal to 1. So now, if I divide both sides by x to the power of negative 1, these two would cancel out, so I would get x to the power of x is equal to, well, 1 over x to the power of negative 1, this is equal to 1 over x to the power of negative 1 is the same thing as 1 over x to the power of 1. So this would be 1 over x. And 1 over x, well, this is simply equal to x. So 1 over x to the power of negative 1 is simply just x. So now we get x to the power of x is equal to x. And now x, the exponent for x is actually 1, right? So we have x to the power of x is equal to x to the power of 1. And as you can see here, we have the same bases for both of these, meaning if we have the same bases, our exponents are the same as well. So that means if we set our exponents equal to each other, we get x equals 1. So we get x equals 1, and this is a solution. However, as you can see here, remember this equation? X to the power of x minus 1 equals 1. Well, I'm actually going to rewrite this as x to the power of x minus 1 equals x to the power of 0. Because 1 here, 1 is the same thing as x to the power of 0. Now, we're going to do the same thing what we do here. We're going to set our exponents equal to each other. So we're going to set x minus 1 equals 0. And if we add 1 on both sides, we get x equals 1. So this is another way of doing it. And actually, we have our solution as x equals 1. However, there is actually another solution to this problem. X equals -1. This would also work as well, because if we plug this into our equation, for example, -1 to the power of -1 equals -1. Well, -1 to the power of -1 is simply 1 over -1. And this is equal to -1. And 1 over -1 is simply just -1. So -1 equals -1. So this is right. So x equals -1. This is also a solution to this equation. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 3 minus x squared equals 100. Now, what we're first going to do is, as you can see, both of these terms have x in them, right? So the best thing to do is to factor out x with the highest degree, which in this case is 2. So we're going to factor out x squared. And that would help us simplify our equation by a lot. So if we factor out x squared, x to the power of 3 divided by x squared, well, that's x to the power of 3 minus 2, which is x, because x to the power of 1 is x, minus x squared divided by x squared is simply 1. So we have x squared times x minus 1, and this equals 100 still. Now what we're going to do is we're going to change 100 into 25 times 4. 100 is equal to 25 times 4. And this is still equal to x squared times x minus 1. Now, this gives us two equations. We would have x squared equals 25, and x minus 1 equals 4. Well, for x squared equals 25, if we do the square root on both sides, we would get, well, the square root of x squared is simply x equals, the square root of 25 is positive or negative 5. So as you can see, this is one solution, and x minus 1 equals 4. Well, we would add 1 on both sides, and if we do that, we get x, these two cancel out, equals 4 plus 1 is 5. However, as you can see, 5 is already one of our solutions, so this is just unnecessary. We already have this as a solution. So we have x equals 5 and negative 5. Now, why don't we plug these two into our equation and see if they are right? Let's first start with 5. So we would have 5 to the power of 3 minus 5 squared equals 100. Now, this would equal, well, 5 to the power of 3 is 125, and minus 5 squared is 25, and 125 minus 25 is 100. So 100 equals 100, and This is right, so 5 is a solution. Now, why don't we plug in negative 5? Plugging in negative 5, we would get negative 5 in parentheses to the power of 3 minus negative 5 to the power of 2 equals 100. Now, negative 5 to the power of 3, well, a negative to the power of an odd number is still going to be negative. And 5 to the power of 3 is 125. So this would be negative 125 minus negative 5 squared is 25. And negative 125 minus 25, well, that's negative 150. And that is not equal to 100, so this is rejected. And 5 is our only correct answer.